So, am I audible? Last?
Yes,
Yes,
sir.
Great. My screen is also visible?
yes, sir.
Yes, sir.
Great. So, today we'll start where we ended yesterday. So, how was the quiz?
Was good, sir.
Easy.
Sure. So it should have been difficult.
No, sir, that was nice.
Any other comment on the quiz? Anything which you could not understand, you want some discussion? Yes. Everything perfect?
Sir,
I'm saying that any other point about the quiz which you would like to discuss or you want to talk,
sir,
clarification, anything? Nothing?
it's not about the quiz, but I have a doubt regarding degree of freedom.
Tell me.
So, what is the importance of finding out the degree of degrees of freedom? So, why do we use it?
I'll give you a simple example, probably that will help you. Suppose you have got summation of 10 numbers. How many numbers? 10 digit. I mean, 10 numbers are there. 10 numbers, let's say real numbers or integers. 10 integers you have, and you know the summation of that. So it means you have 11 numbers, 10 integers, and 11th is the summation of that. So once you know the summation, then you have a limit that you can play with 9 items. Because if 10 is also fixed, summation is also fixed, you have no freedom left. So when we say that we have got, when we want to find out some coefficients, then certain things become fixed. Like I'm saying in the example of this integer and summation. So once things are fixed, then how much freedom you are left with. So that freedom which you are left with is known as degrees of freedom. In this example which I gave you, degrees of freedom is 9. You have number of observation 10. So usually what happens when you have whatever number, so 1 degrees of freedom immediately goes away by the time you would have estimated 1. If I have to estimate one more thing, then degrees of freedom will go down by 1 more, so n minus 2. So likewise, it's a different type of concept altogether, but basic idea is when you have situations in numbers or quantitative, then how much freedom you are left with in a given situation. That is known as degrees of freedom in that given situation. So this is the easiest way to understand. Summation example will work. 10 integers, summation fixed. So once you have estimated the summation, then how much freedom you have to play with the data, that is only 9. Because 9 you can fix, but 10th you have to keep it open. So one is, your freedom is curtailed by 1. So that's why we call that degrees of freedom which is left. In this case is 9. 10 minus 1. That is the simplest way to explain degrees of freedom.
Got it.
Otherwise, if you try to search, you will find that things are much more complicated, but this is good enough. This idea is good enough, which I gave to you. How much freedom you are left with, that is the reason. Yes, more questions, doubts? Anyone else? So today we'll try to wind up regression and we'll start dummy variable regression, the next topic. We started with introduction of financial econometrics, And that was first session. We had 4 sessions, including yesterday's session. It was total 5 sessions we have gone through. So today, practically, I should have started dummy variable, but I thought I'll give you a good revision type thing about the regression so that before you start doing the assignment on your own, you will have some idea, some revision of what we have done in previous 4 sessions of regression analysis. That is recap, but still you are free. And in a way, I can say it is a last chance to those who have so far not paid attention to regression analysis. So even if you ask something which is very basic, I have no problem in answering that. So this is the last chance to understand regression. Those who have understood, great. Those who have even doubt, they can ask questions. And those who have not started or having big difficulties, they can also make an attempt to understand. I'll start from the scratch when it comes to regression analysis. So I think your CRs would have shared with you caselet, CEO salary. Have you gone through the caselet? Yes or no?
Yes, sir.
Yes, sir.
Yes.
So CEO salary will have a dummy variable also, but we are having an regression analysis, CEO salary. So this was the caselet, which was supposed to be read by you. So I believe that you have gone through it. I'll show you data as well, so that all of us are on the same page. So this is the data which we have for CEO salary. You can, for timing, ignore these 3. These are the log values of the same thing. So all salaries are in thousands. So $1,000 have been kept aside. So only the $1,000 state values are given to you in the form of salary. Then you have variables. Description of variables are there in the here also in the caselet. As you are finding in this data set, you are given 4 variables. So similarly, you are finding along with salary, you have got 4 independent variables. Salary is there, salary of CEO and $1,000. Sales. Just this first and last have got interchanged. So this is the turnover or not. Just state simple sales. Then in the above next row is market value of the firm, which we also known as market capitalization, which is again measured in dollars. Then you are having first 2 variables. First variable in the list is CO10, it means tenure of the CEO in the firm. And then next is tenure of that person in the company. So what we are having, the caselet, okay, instead of I explain, any one of you would like to volunteer? What is this case all about? And I would like to have somebody who usually do not speak. Come on, tell me in brief, 1 or 2 lines or 30 seconds, 45 seconds on caselet. What is this case all about? Come on.
Sir, we are trying to find the tentative salary of the CEOs based on the company's market value, the kind of time he has spent in the company, his age, basically.
What Tanay is saying is perfectly all right, but my question is why at all we are interested in this type of study? What has prompted us? What is the motivation behind this study? Why at all somebody would be interested in doing this type of thing? Anyone
Hello,
else?
sir. I'm
Yes.
audible.
Yeah. Audible. Tell me.
Yeah, so many times the CEO they face the brunt of actually accepting the salaries even if the company is not functioning well. So
Okay.
this model is actually trying to estimate the factors which actually help to determine the salary of a CEO. For example, one of the factors which we have considered is the market value of the firm and even the performance of the firm. So this model is actually trying to give a correct an estimate of how the CEO's salary should be computed given the conditions of the business.
So do I have somebody among you who differ with this idea that CEO is putting in his best possible efforts, so he should be compensated. Why he should be compensated less? Because when the time is difficult, he needs to put extra efforts. So there is no point of looking at the salary from the performance point of view. Rather, it should be other way around. So I mean, it cannot be a direct correlation between the present performance and the salary. Rather, performance today, performance of the CEO can be seen only in the future. So, do we have somebody who differs with this idea? Anyone of you who think that no, this is not the right hypothesis to start with? CEOs should be paid what they are supposed to be paid. That's it. Do I have somebody? Come on. We'll come to data. We have all the things with data, everything will be doing it, but let's talk. Yes. Nobody differs. Everybody thinks so genuine, so ethically correct. And I mean, this is also ethically correct to say that CEOs are putting in good effort. So how can the performance be linked to his salary? Future in the 5 years, 7 years down the line, you might see to it, but not right now. Yeah, go
Hello,
ahead.
sir. Nishant here.
Yeah,
So, in cases of salaries of CEOs, what usually happens is that they have fixed component as well as variable component, and that only the variable component which is linked to the performance. Sometimes they are given the ESOPs also. So, it is not that there will be a perfect correlation between the independent variables which we are given in the study. There might not be a perfect correlation. There might only be a partial correlation. So, in that case, it's not CEO will keep getting some salary even if the performance is bad. So there can't be a perfect correlation. That's what I think.
Okay, understood. Any other point of view? Because if you look at the variable which we have taken in this caselet, what you are finding, one is obviously linked to the performance of the company. But if you look at first two components, then they are talking about loyalty of the individual with the company. So do you think that it is justified to have this type of variable in the analysis? Loyalty, which is not tangibly linked to the performance of a company. Somebody is staying, rather at times people say, if somebody is staying in a company for more than 3 or 5 years, it means that person does not have any other opportunities elsewhere. That's why he's sticking to it. It means when you are compensating high to somebody who's staying in the company longer, it means you are practically promoting inefficiency. Can we think that way? So do you think that these variables are justified? Come on. Shall we have them or shall we?
Sir,
We should
I
not
think
have
in
them.
regression,
No,
often
regression
lot of
comes later on. Listen. Regression comes later. First, we need to talk. Talk means why we are doing this study. Study, what comes first? Problem comes first or the study comes first? Problem comes first. So what is the problem? Problem, as some people started with, I think Akshay started that CEO's salary is a debatable issue. That is perfectly all right, 100% genuine. If you look at Vishal Sikka's case, what happened that Narayan Murthy had differences with his salaries and a couple of more things, which the salary which he was offering to his subordinates. So likewise, many cases you will find where the salary of the CEOs are debatable. So that issue is correct. But when we are trying to address the issue, is it correct to have these loyalty elements in the salary component?
So the loyalty element could also be as that the guy knows the company perfectly in and out. That could be one factor.
So you think that, Tanay, that it is justified to have, at least we can try, we can find out whether it is there or not, whether the salaries are linked to loyalty or not. This is what we are trying to find out.
Yes, sir.
Yeah. So partly we can say, yes, the performance driven variables and loyalty driven variables, both, after all, this is what we are going to check. We'll be running the regression. We'll be trying to find out whether salary of CEO is linked with performance of the company or it is linked with the loyalty element of the individual. So we'll see when we run the regression, we'll be in much better position to tell what is happening because all the data is real. So study or the observations will also be real. So we'll start with the first question. Try to establish we'll go through the questions first, so that then later on we'll start with the first question first type thing. So first is try to establish the association between CEO salary and identified predictors. Predictors, explanatory variables, regressors, independent variables, all are the terms which are used interchangeably. So we may try, we will put this as dependent variable and we'll have all these 4 variables as independent. We'll try to find out what is the association. Move to the second point in the caselet. The second point talks about log transformation. What do you understand? Look at the data. Then anyone can comment anything that why at all shall we go ahead with the log transformation in this case? What may be the logic? Look at the variables. These are the variables which we are having at our disposal. Salary, company tenure, CEO tenure, sales and market value. Now tell me, can we justify, let's have a discussion on transformation, log transformation. Do you think that this data is consistent?
Sir, as mentioned last time, like
Yeah.
the data is like we have 9 to and 23,000.
Okay.
Like the range is very big, so we
Correct.
need to put it in a similar kind of range so that it can be better measured and interpreted.
So this point has to be noted. All of you should note it. I mean, what happened that when we practically run the regression, everything cannot be brought into the consideration at one go. Rather, we do one step, then we recognize, no, something is not working, let's try something else. And then in totality, at the end, we probably end up with the best possible scenario in terms of using all the things. So this can also be one of the clear-cut reason, as you were saying, that we are having the data, these three data in thousands, and these two data in, let's say at the most highest is, you can have minimum, maximum, and then you will find that there is inconsistency in terms of scale. So this is a fit case where log transformation of the higher value should be done. All 5 cannot be go for log transformation, that these three need to go for log transformation. And when we do the analysis after running the regression, again we have to keep this in mind that we have gone for log transformation. So that is what it means. When we go for log transformation, it should not be just done and forget. No, you need to keep this in mind that you have transformed the data from normal to log transformation. So accordingly, when you do the analysis or interpretation, you have to take care that data would have been log transformed. So third question, find out the relevant predictor and the relative importance. So how to find out relative importance? Next question. How to find out relative importance? Any one of you, any volunteer?
So the standard coefficient.
Standard coefficient will help us to find out the relative importance of the independent variables or regressors used in the regression. Perfect. So next is, as a consultant, do you find that existing data support the hypothesis that CEO salary is linked? We'll see to it. We'll see to it whether the CEO salary is linked to the performance of the firm or loyalty. That is the big question with which we started. So we'll see to it when we run the regression. And then predict the range of CEO salary if all the predictors are at their median levels. You have studied the mean, median, mode and all. Can anyone tell me what is median? We are going to use this at two places at least today. So tell me what is the interpretation of median. What is median? Why at all it is important? Yes?
So
Yes.
median is the middle. Median is the middle value in the entire data set.
It's a big interpretation. Middle value all the time, or we need to do something before that?
So arrange the data in descending or ascending order.
When we either arrange in the ascending or descending order, then the value of the middle item number can be termed as median. Now my next question. Why median is important when we talk about salaries? Come on. Why median is important when we talk about average salary in an organization? People never go for arithmetic average or mean, which we call, rather they go for median salary. Why? Even when placement takes place, then people say, no, no, don't tell me average, because average may be biased, lopsided, because of either a few would have got too high salary and many would have got too few salary. So it is better to always find out why it is justified to have median salaries. Come on, please react to it.
Exactly as you said, like if we have skewed data, like very big numbers at the end or very small numbers, then the average might go into that direction, but the median will still stay there and it will give us an idea of what's the
So if I answer will take it. If I ask you one follow-up question, that can we put, I mean, these two in two different brackets, that when on one hand we have got arithmetic average, a geometric average, or harmonic mean on one bracket and median and mode on the other bracket. Can we do that? Yes or no? And if we can do that, then how? Why we are supposed to put them into separate brackets? Yes. What is the other type of difference between median and mode and mean, arithmetic mean, or geometric mean?
So I think one reason can be the arithmetic mean or geometric mean can be usually fluctuated just because of a single large value. And if you
That is
compare
okay. That we have discussed. Any other thing? This is okay. Perfectly all right. Any other thing?
Yeah.
Any other thing? So we usually call these median mode as positional average, and these are mathematical average, because position, median is what? A position of middle item number, the value of middle item number, it is coming because of its position. So that is the slight difference. We'll use median today also. So we'll be predicting the salary using the median. We have got data, we'll calculate median of all the relevant predictors, and then we'll forecast that what would be the median or average CEO salary, which would be there. So we'll address the issue quickly. We won't take much time today, at least on this issue. All of us would have been doing this for last 4 sessions. So we'll quickly go ahead with that. So let me get the data first. By now, I believe that all of you must be using both the softwares, at least most of you, I believe. If you are not doing, please start doing. If you have got you have done some work on one software, try to do it on the other software also. So here we go with the case. Let's see your salary, and here it is. So I'll just select that, import first row as the variable name, and we can check that we have all the variables perfectly all right. Here also we can find out variables are shown. So right now, if I just try to find out the first is try to establish the association between CEO salary and divided predictors. So what we can do, we can go for regression, and salary is a dependent variable, and then we can have COM10 and CEO 10, and then sales. Then we can have MKT value, and here we go. We are having everything ready. We are using val only. So these are the independent variable we have taken on these four, and this is the dependent variable. And that is the model which we are trying to assess is, we are trying to find out y is equal to beta 0 plus beta 1 x1 plus, all of you are free to ask anything. Whether I would have discussed that thing earlier, doesn't matter. You are free to ask anything. So I've got 4 variables, so I am practically running this model, and in which this y is nothing but salary, and x1 is CEO 10, and this is company tenure, and then we are having the I think one was market value, other is sales, and this is market valuation, and this is salary. All of you are with me? This is what we are trying to find out. We are testing whether out of, because as we were discussing, these two variables are representing the loyalty portion, and these two are representing the performance of the firm. So we are just going to understand what is impacting the salaries. This is CEO's salary. So this is what we are trying to test. And as we run, all of you are together, all of you are on the same page.
Yes, sir.
Here we run, what we are finding that we will straight away look at the p-values. Because as we look at the p-values, we will find out, and as we are finding that p-value of company tenure is insignificant, CEO tenure is coming out to be significant at 5% level of significance, because p-value is less than 0.05. You remember we have discussed one universal null hypothesis for beta H naught beta j is 0. This is the universal null hypothesis whenever we are coefficient in a regression model, and we'll say bj is not equal to 0. This is the and we have also understood very well that p-value to reject the null, p-value should be less than 0.05, and I have told you to cram it, because I can't waste time on this issue that how or when to reject the null. So you need to just remember this much: to reject the null, p-value should be less than 0.05 at 5% level of significance. Obviously we have got two more popular significance level, 1% and 10%. So, but those are extreme cases. So normally we go for midway. Midway is 5%, 0.05. So keeping that in mind, as we go through, first is p-values 0.298. P-value is not less than 0.05. So we cannot reject, and rather in the case of first is company tenure, what we are finding that p-value is not less than 0.05. So conclusion is null cannot be rejected. So when null cannot be rejected, so we'll say that it cannot be rejected. So we'll say that I just shown it other way around. Let me correct it. It's not taking practically. So this is correct. We can't reject it. So we have to assume that CO tenure is practically equal to 0. As we move to second item, company tenure, sorry, we were talking about. Right now we are talking about CO tenure. CO tenure p-value is 0.014. If we follow this rule, this is a generic pair of hypothesis. So in the case of CO tenure, p-value is 0.014, which is less than 0.05. 0.014 is less than 0.05. So conclusion according to this is reject the null. So if I reject the null in case of beta 2, I write it here. Beta 2 is equal to 0, H alternate beta 2 is not equal to 0. So if I look at that, in this case, reject the null. So we have to reject the null. So beta 2 is non-zero. So beta 2 is relevant. So first variable which we are understanding that it is going to work for us in this analysis is CEO salary is the dependent variable. First variable which is coming to us, which is significant, is CEO tenure. What is the duration in which the company is, the person is CEO of the company. So this is significantly impacting the CEO salary. Look at the next item. We can talk about sales. Look at what is this value. This is 0.055. If I go by this idea, 0.055. So So 0.055 is slightly ahead. 0.055, it is, very close to points. I mean, hardly this 0.005 is the value which is different in p-value number. So what we can say, we have got two choices. Usually when the cases are like that, we accept, we say that this can be marginally, the term which we use, marginally rejected. I mean, or as we say, marginally significant. Why? Because we can consider that they are marginally same because they are at the borderline. So if I have to reject it, I have to accept it. I'll say no. This value is more than 0.05, so we can't reject the null. We do not have sufficient evidence. We reject the null only when p-value is less than 0.05. In this case, p-value is not less than 0.05. So we'll say that we cannot reject the null, rather we have to accept the null. It means this beta 3 is equal to 0 cannot be rejected. That can also be done because p-value is not less than 0.05, rather it is more. So technically we can accept. But this is also a situation if people are interested in having some relationship of sales with CEO salary, they will say that we can even reject also. And the reporting logic is that it is marginally, we will reject there's a marginal impact, and we'll say marginally it can be considered as significant, or it is not equal to 0. Rather, sales is marginally impacting the CEO's salary. So that CEO's salary, so that discussion can be done. So that depends. That depends how you are interested to have sales play a role in determination of the CEO's salary. So this is a marginal case. I repeat myself, this is a marginal case. Even 0.06 at times people use as it is marginally significant, and they say that the p-value can be considered as it is rejecting the null, and this variable can be considered as significant. So that depends. So this is the marginal case. You can do both. Moving to market value is clear cut 0.012. 0.012 is clear cut less than, if I talk about this, beta 4 is equal to 0, H alternate, beta 4 is not equal to 0. And what we are finding that p-value is coming out to be in this case 0.012, and 0.012 is less than 0.05. So we'll say reject the null. So if I have to reject the null, so it means I'll say that this fourth variable is nothing but the market value. Fourth value is nothing but the market value is significantly impacting CEO's salary. So if I do the total analysis as I was talking here, then we can say there are two are clear cut. If you look at this quickly, then you will find that two are clear cut. First is CEO tenure is clear cut significant, and market value is clear cut significant. So two I can straight away write down here. And third, I can consider, but with a rider, with a pinch of salt, I can take it. I'll say that sales is also, but impacting it is significant, but not perfectly significant. Rather, it is marginally significant sales. So this is what we have done the interpretation of this model, which we have just tested. And here we have not bothered, we have not used any common sense of bringing the consistency in the data. This we can do in the next analysis. So right now, we will start doing that analysis. We'll be checking the regression using the log data. So meanwhile, anyone has got anything to talk about, to discuss, to ask? Do I have any other question? So there are different ways, here also you can, if you look at this, I have this, I can straight away use ln is a natural log we calculate usually in finance. So if I have to calculate log of sales. So this is the formula equal to ln, and I've got, as you are finding, these two are same. So this variable has been converted from salary to L salary or log salary. This is the one way by which it can be done. Suppose here I want to do it. I have already created the, let me put it double L. I'm writing double L just so that you can understand, or L sal is equal to, I'm trying to generate, I'll write gen. Gen is a command which is used in Stata to generate a new variable. I'm giving the new name SAL. I'm trying to calculate the log. So log bracket, I'll put the name of the variable which is already there. So name of the variable is salary, SALARY. And if I enter, as I'm finding that one new variable would have been created, I can go here, I can see a new variable LSAL has been created. And if you check, then LSAL is similar to this. I've just done this calculation before. So this is the method by which you can calculate the log values of any number in Stata. So just because it has already been done, as you are finding that I have already calculated log of salary, log of sales, log of market value. We have discussed, just because these are of higher values and these two are lower values, so there might be some inconsistency. Just to avoid that inconsistency, if you compare these three with these two, you will find that now data is in comparable level, which was not the case earlier when we had non-log values of salary, sales, and market value. But having converted salary, sales, market value into log numbers, what we are finding is that now if I can hide it, and then you can probably have better, you can see now these are incomparable situations. Now there's no problem in running the regression with this data, but earlier it was not the case. Earlier, we had a case in which there was inconsistency because these were in higher orders. So coming back, we'll again run this. I'm just going to put L because already I have calculated that way. So I'm just putting L, and I'm just trying to look at the change in the regression. What we are finding here is, just compare this. Look at here the set of p-values where only two are clear-cut significant: company tenure and market value. On the other hand, what you are finding here, practically all this market value is marginally significant, but all the other four variables, four predictors are coming out to be clear-cut significant. So, and you can look at other things also, like, adjusted. This is the previous regression. I repeat, this is the previous regression. Look at here, regression, salary, sales, market value, where log transformation has not been done. Look at adjusted R square is 18, and MSE, this is nothing but the standard error of regression. If you have remembered me, I have told you this error should be as less as possible. But again, there is nothing like R square, where 0 is least and 100% is highest. So we have to, but right now we have got two cases, so we can compare. If you look at here, adjusted R square value is right now it is 33%, earlier it was 18%. So R square wise value would have been improved. Root and mean square or standard error of the regression is 529, and now it is point something. So it is a considerable change in the error of regression, standard error of regression. So keeping these three things in mind, we have got more number of significance. I repeat, whenever we have to compare model, these three are always standard: number of coefficient terms. Second, adjusted R square. Third, standard error of regression. These three are always compared when we are comparing the model. You can now note it down if you have not done. These three things are to be compared all the time whenever we are comparing the model. 1, 2, and 3, number of significant explanatory variables or independent variables. Then usually adjusted R square. And third is standard error of regression, which we also call SER. These three should be compared, more the better, higher the better, and this lesser is better. So that is the idea, to compare the models. Keeping this criteria in mind, I'm going to repeat this. As I move to a RIMA model or VAR model, my next topic after dummy variable regression, we'll talk about these so frequently. So keeping that in mind, we will say that this model is much better and using the same logic, and market value is marginally significant. So now I can say my model, this model which we have tested, but the only thing is we have changed the salary, sales, market value into log transformed variables, and then we would have run the regression, and what we are getting, all the beta 1, beta 2, beta 3, and beta 4 are coming out to be significant. So now if I have to do the discussion on the CEO salary, under the first point, I'll say that out of 4, 3 are strongly significant. 3 means CEO tenure, company tenure, and sales of the company. These are significantly associated with the CEO's salary. Fourth item which we have taken into consideration, market value is marginally significant, but it is significant because 0.056 value is not that big value from 0.05 that we can ignore. So we'll say that it is marginally significant. So market value is also significant. It is also having its impact on the CEO's salary. So that is the answer to the first question. And we have partly answered the second part also. Log transformation, why we have done, why it is advised, that type of discussion also we have done. So these two we have. Third point is, so when I'm saying, yeah, somebody is trying to ask something.
Yeah, I have a question, sir. Sir, I understand that when we are using the log and there is a difference in the standard error, standard deviation, and the this stand we
R
are
square.
adjusted R square and R square because
I
that
gave
is
you this. Please,
model.
I gave you these three things.
Yeah,
Number of
I understand the
significant.
second and third.
Okay.
I get an intuition of why that is changing because that is a whole model, but I do not understand how does the significance of an individual variable changes when we are doing a log transformation.
No, you want to ask that why log transformation is giving higher value of first. This is what your question is.
Yes.
There's nothing big deal in this, because when your data is not consistent, then you won't be able to get the right model. So model will obviously give you more appropriate result when you have data in order. Somebody was discussing yesterday about sample issue. So sample issue is not there in secondary data studies. Rather, this type of, yesterday also I talked about log transformation thing. So these type of things we take into consideration because sampling is not an issue in the secondary data study or econometric study. So when data is inconsistent, you can't expect great results. But when data is consistent, we expect the good result. And obviously, when I'm running a model like this, why I'm running this model? Unless until I have got some conviction, I'm running this just because I have got some conviction that this, which is nothing but the CEO tenure, this is company tenure, and this is sales and market value. So my conviction, it is my conviction that these four things are going to predict the CEO's salary. So I am running this because of my conviction. So now obviously if my conviction is correct in a model which is having the consistent data, so obviously I'll say that the model which is giving me better result or giving me more number of significant items is obviously a better model. So this is very obvious. This is very obvious because my theory, I'm interested in proving my theory. And the model which proves my theory obviously is going to be seen in a better light because I have not brought these four variables just because it was my whims or fancies. It is not my vagary. It was based upon certain theoretical input in which I would have decided that I'll be trying these four. And if I'm trying to prove certain theory and it is coming out to be more accurate or more meaningful, obviously I'll consider that model as a better model. I hope point is clear. So this is the theory which helps me in proving that this model is better. If there is no theory, it is hit and try, then I think we can ignore. But just because it is theory which is supporting me, so I would like to go by my theory that a model which is having higher number of significant is a better model, obviously. Yeah. You have something else, feel free if you differ with me, no problem. Yeah, go ahead.
No, sir, I just wanted to ask that only. Like,
I've tried to support you. I've tried to explain to you that it is the theory which supports me to have that. And when we run more advanced model, obviously, like I'm just giving you something in advanced form, like ARIMA model, when I'm running ARIMA model. So I have the autoregressive terms, and I'm trying to check as many autoregressive terms which can be associated with my model. So because after the significance, I'm not interested in anything, because the last autoregressive term which is going to be there in AR auto or ARIMA model will decide the level of the model. So I'm obviously interested in having maximum number of significant terms. So in a way, there are more situations will come across where it is very obvious to accept a model which is having higher number of significant independent variable as a better model. So this is, I can tell you, we'll have more such occasions when we are going to use this logic. Right?
okay, sir.
So if you want to, say then remove the theory and then remove the variable. So when you are not having theoretical support, you will be testing with the lesser number of independent variables. Then there is no point. When you have lesser number, and then within that maximum number of the model which is having maximum number of significant variable will obviously be a better model. So theory is at our rescue when we put forth this idea. Yeah. Anything else which anyone else would like to ask? Okay. So we were talking about this output. Where is the output? Yeah, here it is. So this is what we have found. We in our regression output also we will be reporting. As we are seeing this, I'm not noting down. You want, I can. So we can, we can note down everything. We can enter. If I'm interested in knowing I'll show you the standard coefficient. I'll run that. I'll calculate the standard coefficients as well. So F test, if I just look at the F test is this is 22.90 and OP values are 000, means quite less than 0.05. Null is rejected. If you remember the null for F test of model is that model is not good, and alternate as model is good. So when we say that p-value is less than 0.05, so null of model is not good is rejected, and we are accepting that model is good. So here we need to report. So here the coefficients, what we are seeing right now, then corresponding SE. If you look at here, these are standard error. Right now we are not making use of standard error, but doesn't mean that there are people who use standard error to understand the strength of your analysis. So you have to help them. So that's why you need to report standard error. T value can straight away be calculated by dividing coefficient by error, but matter of convention, we are supposed to report t-values also. P-values should invariably be, even if you don't report p-value, people will comprehend the result with the help of t-value. But just because this is t-distribution dependent upon certain degrees of freedom, so it is always advisable to help the reader who is reading your analysis to provide all these things. Standard will calculate. So value of coefficient, standard error, t-test, and p-value. VIF, will come to it. We have discussed yesterday also that when we run the regression, then we have to talk about diagnostic testing. We'll just come to it. So coefficient analysis we have done. model interpretation we have done. These two things we have done in this case. Now we'll quickly go through diagnostic testing. All these three, autocorrelation will not be testing because it is cross-sectional data. And then we'll go for parametric stability. We'll look at the specification, whether there is any specification error or not. That is the idea. Here we are, nothing else as such to be discussed. Yeah, one thing I just wanted to show you, the comparative level. So I'm just only adding comma and beta will give me the standardized coefficients also. Now look at these values and we'll look at these values in absolute sense and look at this, which is the highest. So what we are finding that sales is having the highest impact, and after sales, what is having the bigger impact is CEO tenure. After that, company tenure. And one thing which should also be noted, this also we just ignored, that company tenure is negative. Means if somebody would have stayed in a company for a longer duration, then he is not respected in terms of giving more salary. That's good interpretation. Class, you're with me? That's a good interpretation that company tenure is negatively associated with the CEO of the salary. It means if you stay in a company at a junior level and you are promoted to CEO, take this for granted, you won't be given good salary. But if you are becoming CEO of a company, coming all the way from outside, you will be compensated more. So I don't know how to look at that, but it happens across the board. I mean, good number of companies I have seen that they follow this. Visibly present here. So when we are talking about relative importance, so most important variable or predictor in determining CEO salary is good sales. So good sales can be one measure of good performance of a company, though it is not the growth rate, but the level of sales. So high sales can lead to high salary. Then second important is how long you have been there as a CEO. Longer the duration, you would be able to command more salary. That is visibly present. But coefficient is not very high. But I'll give you a little more help because I'm using log. So I can talk. I'll talk about it. So as long as relative importance, most important is sales, then CEO tenure, then next important is company tenure, but in negative sense. Negative, I'm not picking from here, I'm picking from here. When we say relative, we look at absolute. And then least important thing is market value. And that is also we are getting with the help of this. This is marginally significant. And that is partly also coming true when we look at the relative importance of predictors. So I guess this is a good interpretation, good support of data to discuss certain things. Anyone would like to ask anything? Or I can quickly go through the diagnostic testing. Anyone?
No, sir.
And so I have to go for testing the heteroscedasticity. We have discussed why we need to test heteroscedasticity. We have been discussing that diagnostic testing is essential because though it is not, it's like intangible thing, which is not tangibly present, but diagnostic testing is looking at the strength of your estimation. So far, whatever we have talked, that is based upon certain strength of the model. And the strength of the model, that is okay, that we have got R square, standard error of the regression. But the estimation mechanism, whether it was in proper shape or not, that is what diagnostic testing is. So it is like, you buy a car because it is giving you good mileage, but you don't know whether the strength of the engine of the car is good or bad. So whether the body is strongly built or it is very light body. So when you meet with some accident, what is going to be your fate? So those things can be decided when you look at the whole car in totality. So engine, strength of the body, these things can be compared. If I use the analogies, I'll say that this diagnostic testing of that league, it talks about the things in a different dimension. So it is not tangibly present. Tangibly, we are just going through model and coefficients. But these things should surely be tested because they tell the strength of your analysis, whether the analysis at the first go was appropriate or not. So reporting of these are essential. And if you have problems here, then whatever is there can be questioned. And practically, if you have doubts here, then whatever you are talking may not be given much weight, or whatever you are saying this will be seen with suspicion, because this part tells, I mean, your engine of your car is not great, the safety of your car is not great. I mean, that is something like that. So diagnostic testing, including parametric stability, may not be apparently present there, but they are much more important in a way, I can say. So we should never ignore the third and fourth point in regression analysis. Rather, they are more important than first and two. First and two are maybe meaningless if you have questionable situation in third and fourth. I hope I have made my point clear. Diagnostic testing, parametric stability, they may not be visibly present to tell you the story the way coefficients or model are there to tell you a different type of narrative, but they are very essential. I'm open to discussion on this issue. Diagnostic testing, we talk on three fronts. Heteroscedasticity, which is all the time there, whether it is cross-sectional data, time series data, or panel data. You will see that we are talking about these three, the heteroscedasticity all the time. When we talk about the other two, multicollinearity is there whenever you have more than one variable as independent variable. Again, whether it is cross-sectional, time series, or panel, multicollinearity is part of the discussion as long as you have more than one independent variable. Third diagnostic testing important thing is autocorrelation. Autocorrelation is not there when we are talking about cross-sectional. When we talk about time series, we have to talk about autocorrelation. And when we talk about panel data is a combination of cross-sectional and time series. So just because panel data becomes part of the time series data, so we have to talk about autocorrelation and panel data as well. So the only place where we can ignore talking about autocorrelation is cross-sectional data. That is what we are having right now. So we are not talking about autocorrelation. Parametric stability, we have discussed this. That parametric stability talks about specification, as we were talking about right now, that I'm using 4 variables. But 4 variable may be giving me theoretical input, but are they enough? I might have some issue of omitted variable error. I might have missed out some important variable, or I might have got some variable which is superfluous. So that type of specification error, they might be giving me, but when I run this test, I'm better off to find out whether my specification is within the acceptable level or I'm missing out something concrete. So that type of discussion, though the test which we run has got a lot of limitation, there is no test which clear-cut tell you that specification is perfect or not perfect. There's no strong test. Weak test, but as I always say, something is better than nothing. So we make use of whatever test, reset test as we use here, and we try to find out whether the specification is in order or not. So that's why, so I repeat again and again, right now again saying that diagnostic testing and parametric stability should not be taken for granted. Rather, in a way, they are more important than previous 2 types of output of regression analysis. So coming back to the results, E-STAT hit test, and if you remember, I've talked about for all the 3 types of diagnostic testing. If I talk about, let's say, heteroscedasticity, then my null is no heteroscedasticity. H alternate, yes, there is heteroscedasticity. Similarly, when we talk about multicollinearity, is not here, but we'll talk about specification error. The reset test. So there I'll talk about no specification issues. Yesterday I might have used some different words to describe the same thing. Yes, there are specification issues. So this is again the pair of hypothesis which I would be testing. Multicollinearity, I'll just quickly calculate the correlation to complete the discussion, and I'll calculate VIF also to support the understanding what I would be deriving from correlation coefficient. Coming back as I run, so first of all, I'm testing out of these three. I'm testing autocorrelation can be ignored, so I'll ignore it. And then I'll testing heteroscedasticity. First of all, I'm running it and I'm looking at the p-value. P-value is 0.4424, which is not less than 0.05. It means I cannot reject the null. So what is the null in this case? No heteroscedasticity cannot be rejected. So I have to accept that my model does not have heteroscedasticity problem. Yeah, class, you are with me?
Yes, sir.
Yes.
So we move to next. Next is multicollinearity. We'll test multicollinearity. As I have discussed that multicollinearity is tested with the help of I tested somewhere. So we'll go for pairwise correlation coefficient, and I can have all the variables which are there, but I have multiple variables. So I'll quickly go through these two, and then I'll take the log form. So log salary, log sales, log salary can be ignored because this is a dependent variable, or we can take it either way, it is okay. But right now we are ignoring it. So I've got all the four variables, four independent variables. Now I'll say star 0.05 is significance. And look at here. This is the normal formula which I'm using all the time. Look at this output and look at company tenure. It is having the significant association with the CEO tenure, but association is not to the range of 0.8. And I repeat myself, it could be minus 0.8 or it could be plus 0.8. If the correlation coefficient is more than 0.8, I am including minus as well, because correlation coefficient moves from -1 to +1. So it is of strength, whether negative or positive. It is more than minus 0.8 means minus 0.85, minus 0.82, or plus 0.8283. So if the strength of the association is higher than 0.8, either way is plus and minus, we'll say that there may be a problem of multicollinearity. Significant, point higher than more than 0.8 plus minus, or insignificant. So significant more than 0.8 value plus minus including. So right now what we are finding, this is 0.31, which is less than 0.8, though significant. This is not significant, can be straight away ignored. Look at sales and company tenure. This is also significant, but the strength of the association is 0.23, not 0.8, so can be ignored. The only item which is worthy is market value and sales. They are obviously correlated. Market valuation and sales, these are the two things which are obviously correlated. So if you remember me, my discussions which I did earlier, that association is not a problem between the variables, independent variables. Rather, it is too strong association may create trouble to OLS, optimum least square method of calculating the coefficients of regression. So still we are having significant, strong, but not more than 0.8. So it can still be ignored. I can cross-check the whole thing with the help of VIF, but I need to test regression first, then I'll calculate VIF and look at VIF values. Still VIF is not more than 0.4. If you remember my discussion, I talked about VIF, though it is not a deciding factor, but it can corroborate, it can support the results of significant correlation coefficient. But right now we are having the situation where no pair of independent variables are having significant association to the order of 0.8 or more, plus minus included. So same results I'm getting with the help of VIF. No variable in this regression with CEO salary is having a value, VIF value of more than 4. So we'll say there is no problem of multicollinearity. So when I prepare my report under this multicollinearity, I'm supposed to describe this whole story, that correlation coefficient is no pair has got significant correlation coefficient having a value of more than 0.8 plus minus including, and VI value is also not more than 4. So there is no problem of multi-collinearity as well in the given data. Anyone has got anything? So coming to the last item, we have got the OV test or a reset test. I have discussed. This is the pair of hypothesis. No specification issues. Null is no specification issues. So this I have discussed yesterday and before also, or I think yesterday I started with these two. Yeah, this and especially the multicollinearity. So parametric stability, I'm going to test. Parametric stability is nothing but the specification of the regression model which we are running. We would like to know the specification issues, whether some important variable have not been removed or superfluous variable are not part of the system. That we check with the help of this parametric stability test. And right now, I mean, we use this reset test. So to run reset test in Stata, we have got a command known as ov set, ov test. So ov test, when we run, what we are getting, repeat, we are doing parametric stability with the help of reset test, having this pair of hypothesis. Command of reset test in Stata is estat ov test. And these are the values. We look at p-value. P-value is 0.02. I mean, if I round it off, it is coming out to be 0.02. If I go by my simple analysis, if to reject the null, if p-value should be less than 0.05. And right now, this value is less than 0.02, is obviously less than 0.05, reject the null. So my null is no specification issue. It means this cannot be accepted. This has to be this has to be rejected because p-value is less than 0.05. So I have to report that my model, which I've tested, has got specification issues. Now I've got two repercussions. If you remembered me yesterday when we were doing tire racks caselet, we had the issue of multicollinearity. Then I told you the solution of that. Either you remove one of the two independent variables and then you run the model and again you follow the criteria which I have just discussed. This criteria I discussed with you. You follow this criteria, you look at the model which is having a higher number of significant, just because, but in that case there will be only one independent variable, so first issue is knocked out. You would go for out of those two models, means one model with one independent variable. I'm talking about the tire racks caselet. One model with one independent variable, another model with another dependent, and the model which has got higher adjusted R square and higher standard error regression is supposed to be accepted. So that logic will be using there. So according to the problem, solution is advised. There is no motherhood statement in terms of solving all the problems. No, we look at what is the problem, accordingly we'll have a solution. So right now, as we are having the problem of specification. So to address this specification problem, we are first of all reporting this. The second is what are the remedial action, the two possible actions. One you do not do. You just report it and say that result should be seen keeping this in mind that there is a specification problem. Second solution, second remedy. You may try out, hit and try, again add, delete, and try to find out whether this this problem or specification can be checked. The null which is rejected should not be rejected. If you get a situation, great. If you do not, then you have to just report and as I said, that first remedy. Third can be, or rather it's part of second only, you try to incorporate some new variable, try to revisit the theory and then come out with new theory and then you test that. But you never know, there's no hard and fast rule to handle this problem, especially in this situation. Either than this, that you remove certain variable, add certain variable and try to find out that this problem or specification can be handled. Problem or specification is not only limited to having extra variable or omitting the important variable. It is also linked to measurement error. When you are measuring the variable, you might have measured it wrong. Like in this case, when you are calculating the CEO salary, CEO's salaries are not explicitly available. And when you have got the data from the company, they might have underreported. So that will be a problem related to measurement error. So your data, even if the theory is perfect, but if there may be a data which is having the measurement problem. So specification errors are not only limited to having some extra variable or removing the or omitting the important variable, it can also be linked to having the measurement problem. So that is the discussion at this point. So this we have done parametric stability prediction. Yesterday we talked about that. We can put in this regression. We have got this regression model with us. Regression model we have, and if we want to test, so let me quickly note down. I'll open the Excel and I'll run the model for you. And I have to calculate the median values. So is it okay to everyone? All of you are with me?
So what was the second solution?
Come again?
So what was the second solution for the specification problem?
You remove some more variable, introduce some more variable. If it works, great. If it doesn't work, revisit the theory. And if nothing works, then you resort to the first remedy and report it and say that result should be seen with this limitation.
Okay,
Kind of it. Right? So let me complete this whole thing as if I go through the caselet. So we have done the relevant predictors. What we have found practically that all are relevant. As a consultant, do you find that existing data support the hypothesis? Yes, it is supporting. And when we come that what is giving more importance, loyalty or performance, if I just go through it, go through the comparative assessment, what we are finding is the most important thing is sales, and least important is also something related to the performance. So we can say we would like to go for midway, but partly we can say just because the difference between these two is very high, we can say that the performance of the company is given more importance when it comes to deciding about the CEO's salary. Otherwise, all the four are significant, and this is insignificant. So we can say again partially that loyalty is given more or having more say when it comes to deciding the CEO's salary. But this point also to be noted that the longer duration is negatively compensated. So when it comes, which is relevant, then we can say loyalty is more relevant. But what is more contributory, then we'll say that probably these two are contributing more in terms of higher the sales, higher the market value, higher the salary. So that type of analysis in totality can be done if I have to answer the fourth part of the caselet. When it comes to predict the range of the CEO's salary, so what I can do, I can quickly calculate. This is the raw data with us. And what is the caselet says? That predict the range of CEO's salary if all the predictors are at their median level. So I can calculate median level of all that. I have to just run one command. I'll run one command. I'll say median in Excel. I can give that command in some different command there. So right now I'm just giving one command median, and here I've got the median value. So I'm just highlighting by some other colors so that I'm not confused. I'll drag it and I would have got values. So when I'm running this, I need to calculate these three and these two, because I have converted already data from normal to log. So these two are relevant for me, and these two are relevant for me, and these three are relevant for me. Last three. Last three. So I don't know what wrong I'm doing. I'll straight away copy this data from here. I think this works. So here I've got all the three things with me. And so I have to just quickly use the model. I have to tell a few things to you. This first was CEO, company tenure, CEO tenure. So this I've got, and I don't know why this is 6. So, and if I look at the model values are, yeah, this is here. I have the values, CEO salaries. Copy again, here, yeah. Values are, yes. The coefficients we can note down here. Coefficients, these are the median values. Now I'll be just running the regression. I'll be able to calculate the predicted value. So to calculate the predicted value, coefficients are, we have constant also. So constant value is 4.57. CEO tenure is equal to 0.0169, and then we have got CEO tenure. This is minus company tenure 0.0094. Yeah, I'm writing that correct. Yeah. Though the values of coefficient is quite small, but it is there. L sale is equal to 0.1918, and then 1918, and we have got salary. Salary we are predicting, and we have got market value equal to 0.094. So these are the values which I have calculated. I mean, with the help of model, I'll be running this model coefficient plus I'll go for this multiplied by this. I can run some product also, but okay, what we have done. Plus and this is the value which we are getting, and obviously we are getting the value in log. So this value, if I define it, so this value is there in log terms. So it is the y value is coming out to be log, rather put it this way, this value is log y. So I've got log salary, and that value is coming out to be 6.511, 6.511. So I need to convert that into salary to calculate the salary value. You know, this can also be written as log to the base e salary is equal to 6.511. So salary is equal to e to the power 6.511. All of you are with me? I guess none of you have got any issue with this. Converting log to numbers. Class, you're with me?
Yes, sir.
Yes, sir.
I calculate this value. this salary. So I'm just getting the point estimation. So the formula in Excel is EXP, and I just put the value. I'll be getting some number. This is $672,000 is the average salary which we are getting. And again, I'll be using here, but I'll be calculating the range here, and then eventually I'll be calculating both lower and upper range. I'll be calculating range here, lower bound and upper bound, by multiplying the SE. If you look at the SE in this case is 0.4949, we can say SCR is equal to 0.4949. And if I calculate the T value as I did yesterday, so T value, I have to calculate T value. Then I told you TINV at 5% level of significance, and degrees of freedom, I told you this is 172 here. When we have the this table, you'll find that this value is the degrees of freedom. Total number of items minus how many independent variable for 5. Formula was yesterday, if you remember, I gave you formula. Degrees of freedom is equal to n minus k plus 1. N is equal to 176. K is equal to 4 independent variable plus 1. So it should be 171. So 172, I am getting 170. This is already, this is not the total number of observations. This is 177 is the total number of observations. So this is 177. Just so this is 177. So we are 177 minus 172 is the degrees of freedom. 172. When I same thing is there in 172. This value I say that we need to take for degrees of freedom. Here I'll 172 enter. I've got the value. So if I have to calculate the lower value, or I calculate the lower value, higher value. So lower value is nothing. We have to take this. We will convert that the log number into actual number after calculating the lower value and upper value. So lower value minus, we will have standard error of the regression into the level of significance. So this value is the lower, and when we have to calculate the upper value, so this standard error into the t value, and this is what I have got. So if I have to calculate the EXP, I'll be just taking these numbers and I'll be getting the salaries and average lower and upper bound salaries. So these are the salaries. So this is the actual answer. So in $1,000 obviously. So 2,53,000 and 17,86,000. If I just say in converting the $1,000 into real numbers. So this is what we have. This also we have solved. We have given the idea about, with the help of our regression analysis, we have given we have predicted the range of CEO salaries when all the median values are taken into consideration of all the 4 independent variables. So that is the end of it. We have completed the regression analysis chapter also. I'm open to question you have, otherwise I'll discuss about the assignment, and then we'll close the class.
Sir, just a quick confirmation. If p-value is greater than 0.05, heteroscedasticity is present.
No, p-value is the null of p-value. There is no heteroscedasticity. The null of p-value. Look at null of p-value ht. There is no heteroscedasticity. So if you are unable to reject, so when you are unable to reject, when p-value is, when you can reject this, when the p-value is less than 0.05.
Yes, sir.
So whenever you have p-value less than 0.05, you will say that null is rejected. It means there is heteroscedasticity is accepted.
Okay.
So p-value, don't cram this way. I will rather suggest you always remember the associated hypothesis. So HT carries this hypothesis where null is null of no heteroscedasticity. So this is what you need to remember. What is the null? Null is no heteroscedasticity. If null is rejected, there is heteroscedasticity. If null is not rejected, there is no heteroscedasticity.
Okay, sir.
So I'll again say, don't cram the output. Remember the hypothesis. And then you run the test, look at the p-value and give the judgment.
Okay, sir.
Yeah. Anything else? Anyone? मैं अभी कॉल करूंगा 5 मिनट बाद. मैं क्लास में हूँ किसी. Yeah. Anything? Anyone? ठीक है, we come to the end of it. Whatever we have discussed, it will be. Actually, all of you are accessing all the things which whatever I am sharing on this Google Classroom. I haven't started sharing things on MS this team, but today I'll try to share the assignment. But I'll discuss right now with you. So we have done introduction to FE, then we have done the regression analysis. I was supposed to start, but I'll start in the next class, dummy variable regression. All the material I have divided into, I'm sharing with you some study material, hardly 16, 17 pages of PDF, which is good enough for you to go through. And I have kept one small video, hardly 9-minute video, very small video. You'll enjoy listening to it. And then I've got 3 caselet to handle in this. So right now I've not divided things that way. I'm just having one car caselet, mutual fund caselet, and CEO salary. Again, I'll be revisiting with some different variables. So this is the plan for handling the dummy variable regression. We'll try to finish all the 3 caselet in the next class itself. That is the idea. So I believe all of you are getting access to all the material which I'm sharing through Google Meet, this Google Classroom.
Yes, sir.
I don't know, often on I get a request, but when you log in through your official mail ID, you will be able to get the access. Your personal Gmail may not provide you the access to this material. So if you try your official mail ID, it will always work. And if there is any problem, you can always get back to me. I'll try to solve the problem. So here is the assignment. Today you will be having assignment by any channel, Google Meet or this Microsoft Team or through your CRs, you will be having this. I'm showing you the assignment date is today, submission date is 31st EOD. By 12 midnight you can submit. Marks is 20. And please take care, late submission will be treated as absent and you will be marked 0. No if and but. I'm very sorry, we can't entertain that. So from day 1 it is clear. And then you have the caselet is based upon not exactly cross-sectional data, but it is a time series data. I was just finalizing the caselet. I'll discuss with you briefly. Time series data. This is a multiple regression model. And what you have to do, you'll be given set of companies. I have already shared with you I have decided the companies. Assignment. Yeah. So the companies are decided. All of you would have been allotted one individual company. As you can see. So you have been given, all of you have been given companies. These are public limited companies. So what you need to do in the assignment, that you would be building a model in which you would be finding out the determinants of profitability. When I say determinants of profitability, then you can take PAT, profit after tax, or net profit as the dependent variable. And then I leave to you to decide or to take as many or different types of independent variables. You have understood a lot of ratio analysis, and you understand in the common sense also that what are the possible. So I leave it to you to decide the theory, that what are the independent variables, but you should surely have more than one so that the model qualifies for multiple regression model. And then you are supposed to go for running the model. And when it comes to reporting, I've written everything very clearly. I'll be finalizing this, that you are supposed to make one PDF where you will invariably have all the both the tables, table 1, table 2. And then you are also to have this 5-pointer commentary of on all the 5 points what we have discussed under regression analysis. And in addition to that, whatever you want to discuss, you are free. Why, justification, that why you would have taken certain variables. And after the analysis, you can have elongated discussion. You are free to do whatever you want. So marks will be decided on the basis of your strength. I'll give you a rubric also so that you have absolute clarity what exactly I mean, or on what grounds you will be getting the marks. Rubric is a heads, and every head will be having certain marks which will total into 20 marks. So you will have absolute clarity that why you have been given certain marks and under what head you have got more marks. That sort of clarity will be with you. So I'll share with you rubric also in the evening. You have also given me the Excel in which you will be having very neatly arranged data. First column will be dependent variable, like profit of your company of whatever number of years. Let's say this Proves has got data from 1985. So you can have data from 1985 till 2019. Or suppose a company started in 2002, from 2002 onwards. So that is the idea. As old as possible data you are supposed to have for profit, and all the other variables should be neatly arranged in Excel. That is the idea. And I'm available all the way. Whatever you want to ask, you can get back to me directly. You can take my WhatsApp number from CR, and you can bother me, no problem. I'll reply if I'm there, or I'll request you to speak to me as per the case. So, and you can all the way get back to your CRs also for any collective clarification or any other issue which you want to talk to me regarding the assignment. So this is there. Have anything else? I'm still here. That's it. Shall we close?
Hello, sir.
Yeah, tell me. Tell me. Yeah, tell me.
Yeah, just to clarify.